Determine all values of c that satisfy the conclusion of the mean value theorem for the function f of x equals x cubed plus 2x squared minus 10x on the interval -5 included to 0 included. The first thing to do is to determine whether the two conditions are met for the mean value theorem to apply. The first condition is the function f of x, which is x cubed plus 2x squared minus 10x, has to be continuous on the closed interval given. X cubed plus 2x squared minus 10x is a polynomial, and a polynomial is continuous on any interval, so it will be continuous on the closed interval given of -5 to 0. Closed means that it includes both endpoints, indicated by square brackets on both ends. Condition 1 holds true. The second condition, the derivative, the first term is power rule, bring down the power, subtract 1 from it. Second term is a power rule, bring down the power, multiply it with 2, subtract 1 from it. Third term is a constant times x, the derivative is the constant. The derivative has to be continuous, it's called differentiable, on the open interval. 3x squared plus 4x minus 10 is also a polynomial. And a polynomial is continuous on any interval, therefore this is continuous. It's called differentiable when the derivative is continuous on the open interval. It's always the open interval for differentiable because a function is never differentiable on its endpoints. So it'll always be open, meaning it doesn't include either endpoint, indicated by round brackets on the endpoints. But condition 2 does also hold true. Since both conditions hold true, the conclusion of the mean value theorem does apply here. And that says that the slope of the tangent line at some value c will match the slope of the secant line connecting the endpoints, f of b minus f of a over b minus a. For at least one c, maybe more, in the open interval of -5 to 0. In this problem, the interval is -5 to 0. The left endpoint a is a -5 and the right endpoint b is a 0. So the right side can be written as f of 0 minus f of -5 divided by 0 minus a -5. The left side, f prime of c, can be evaluated by plugging c into f prime of x. That will give 3c squared plus 4c minus 10. And this will equal to, on the right side, f of 0 minus f of -5, which can be evaluated by plugging those into f of x. F of 0 will be 0 cubed plus 2 times 0 squared minus 10 times 0 minus f of -5, which will be -5 cubed plus 2 times -5 squared minus 10 times a -5, all divided by 0 minus a -5, which is the same as 0 plus 5. This will equal to 0 cubed is 0, plus 2 times 0 squared is 0, minus 10 times 0 is 0, and then minus -5 cubed. -5 times -5 is positive 25 times another -5 is -125, plus 2 times -5 squared, which is a positive 25, and then minus 10 times a -5 is a positive 50. All of this divided by 0 plus 5, which is 5. So 3c squared plus 4c minus 10 equals 2. 0 plus 0 minus 0 is just a 0, and then minus a negative 125 plus 2 times 25, which is a 50, plus a 50, all divided by 5. So this will be 0 minus negative 125 plus 50 plus 50. 50 plus 50 is 100, and then minus 125 will be a negative 25, divided by 5. A negative of negative 25 will be positive 25, so this will be 0 plus 25 over 5. 0 plus 25 is 25, and then divided by the 5, and 25 divided by 5 is a 5. So 3c squared plus 4c minus 10 equals to 5. Since we have a trinomial quadratic on the left side, we will want to equate it to 0 by subtracting 5 from both sides. So 3c squared plus 4c minus 15 equals to 0. We can now trinomial factor. Since it's 3c squared, it will be 3c and c. And we need two numbers that multiply to be a negative 15 and add to be a 4 after one of them is multiplied by a 3. 15 can be 15 and 1. It doesn't look like that'll work here. Or 5 and 3. And that will work if the 5 is put here and the 3 is put here, so that we have a 9c and a 5c, which can combine to be a positive 4 if the 5 is negative and the 9 is positive. So we will have a negative here for the negative 5c and a positive here for the positive 9c. Now that it's factored, the 3c minus 5 can equal 0, or the c plus 3 can equal to 0. This one, if we add 5 to both sides, 3c equals to 5, divide both sides by 3, c equals to 5/3. This one, subtract 3 from both sides, and c equals to negative 3. We were guaranteed there was going to be at least one c, perhaps more, in the interval from negative 5 to 0. We only want to keep those that are in that interval. The first one, 5/3, is a positive number, and it's not in the interval between negative 5 and 0. So this one will not be included. The second one, negative 3, is in that interval. We were guaranteed there's at least one. There may be more. We ended up with 1. C equals negative 3. That satisfies the conclusion of the mean value theorem.